Hello, hello, hello. So, practice paper 2012, so that's practice paper A, paper 2, 2 hours allowed, calculator allowed as well. Let's go. A bank has these exchange rates for buying and selling euros. Buying euros and then selling them at a higher price. Ben buys euros for £600, he spends €570 and he sells it back to the bank. How much does he get from the bank? Okay, so £1 is equal to 1.15 euros when he sells them. So, when he buys them. So £600 is going to be 600 times by 1.15. Oh. 600 times 1.15, which is 690 euros. So 690 euros is how much he gets in the first place. He then spends 570 euros, which means he's got 120 euros left over. And then finally he needs to change that back using the selling euros ratio. So £1 is equal to 1.29 euros. So if I want to turn it back into pounds, instead of timesing by 1.29, I need to divide by 1.29. So calculator out, 120 divided by 1.29 is £93 and 2 pence. There we go. Next one then, number 2, factorise. So factorise means to put a bracket back in. What number goes into 8 and 10? 2 does, so 2 bracket, and then 4w minus 5, because 2 times 4w is 8w, 2 times 5 is 10. Solving. So, 2 sides to the equation. The left side and the right side, the same to both sides. You want to get rid of the lowest amount of x's to make life as easy as possible. So for us, what is lower? Well, there's 7x or minus 3x. Or minus 3x is lower. So I'm going to add 3x to this side, which means I'm just going to be left with 6. And add 3x to that side, and I'll get 10x plus 2. Now I've done that, I want to get rid of the plus 2, so I take 2 from both sides, which is going to give me 4, so 10x is equal to 4, and then dividing by 10 is going to give me x is 0.4. Number 3, here is a map of Jordan. Dead Sea, blah blah blah. Ezrak is on a bearing of 110 degrees from Amman. Ezrak also lies on a straight road between Karak and Safawi. Mark the position of Ezrak on the map. Okay, so bearings, you just need to remember you measure from north, which is why north is given. You measure in a clockwise direction, and there's always 3 figures, so 110 degrees. So from Amman, there's my protractor on north, and it is on a bearing of 110 degrees. So 110, naught is on the inside, so 110 is on the inside there. So it's somewhere along that line there. And it also lies on the straight road between Karak and Safawi. My Karak and Safawi straight road is there. So whereabouts is Ezrak? It's at this point here. Alright. The distance from Amman to Irbid is 70 kilometres. Amman to Irbid is 70 kilometres. Calculate the distance from Amman to Petra. Okay, well my answer is probably slightly different to yours, but the method will be the same. So, the distance from Irbid to Amman in mine is 1.5 centimetres. So 1.5 centimetres is equal to the distance 70 kilometres. So it's telling me that, so I can work out my scale from that. And now my next job is to work out the distance with my ruler from Amman to Petra. So that is 6.5 centimetres equals to the number of kilometres. To that. Alright, so how am I going to get from this to that? Well, the way I would do it is I'd go down to 1 centimetre on there. So 70 divided by 1.5 will tell me what 1 centimetre is worth. So for me that's 46.67 or 6 recurring kilometres. So now to get 6.5 I times by 6.5 and I get my answer, which for me is 300.3 kilometres. Now then I should imagine your measurements are slightly different, but the same method should apply. You probably get a nicer looking answer than that as well. Hopefully that makes sense. If it doesn't, come and find me and I'll explain to you again. Number 4. A shop's selling washing powder in 3 different sizes. Amanda wants to buy 6 kilograms in the cheapest way. What should she buy? So it's a start question. So you want to be setting your work out in a sort of organised way. Right. So we'll start with the 500 gram box. Well, 500 grams times 12 equals 6 kilograms. That's 6,000 grams. So how much will that be? Well, 12 times by £1.49 is going to equal, calculator out, 12 times £1.49 is £17.88. So that's the 500 gram box. I'll do the next one now. 1.5 kilogram box. 1.5 kilograms times 4 is 6 kilograms, so I need to do 4 lots of the price. £4.45. So £4.45 times 4 is going to be £17.80. Next one. So the 3 kilogram box, 3 kilograms times by 2 is going to give us the 6 kilograms that we need. So we need to do 2 times by £8.99, which is going to be £8.99 doubled, £17.98. So which one is the cheapest? 1788, 1780, 1798. Buying 4 boxes of 1.5 kilogram is the cheapest way of buying 6 kilograms washing powder. Alright, hopefully that makes sense. I should imagine there are other ways of doing that as well. Key to it is just making sure that because of the star there, your sort of setting your work out in an organised manner. Okay, making sure you're sort of explaining as you go along. It's clear exactly what it is you're doing. 50 people are asked how many holidays they took last year. Work out the mean number of holidays per person. So, 22 people didn't go on holiday, so there's no holidays there. 18 people went on one holiday. 8 people went on 2 holidays, so 16 holidays in total. And 2 people went on 3 holidays, 6 holidays in total. So, to work out the mean, we want to add together the total number of holidays. So 0, add 18, add 16, add 6. Tells me that there was 18, 40 holidays altogether. So the mean is 40 divided by 50, because there are 50 people, which is equal to 0.8. So the mean number of holidays per person is 0.8. Next one then, number 6. Straight away you notice the star going on there, so we need to be clear about our working out. In 2009, Jeff ran the London Marathon and raised £825. In 2010, he raised 18% more. Then in 2009, his target was to raise 1,000. Did he reach his target? You must show your working. Okay, again, different ways of doing this, but I would say 18% of £825 equals 825 divided by 100 times by 18. And that is going to tell me what 18% of it is. So, calculator job, 8.25 times 18 is £148.50. So that's how much more he raised. More than in 2009. So in total, in 2010, he raised the £825 plus the £148.50, which is equal to £973.50. Unfortunately, Dev didn't quite raise his target of £1,000, because he's not quite there. Number 7. It's tricky, this question. So, in January 2011, VAT increased from 17.5% to 20%. Here's a formula for working out the price after the increase. So B is the price that it was before, then you use the formula and it gives you the price that it should be after the increase. So the price for an item before the increase was £98.70. Work out the price after the increase. So to do that on a calculator, we're going to do 48 divided by 47, then times by the price it was before. So 48 times, 48 divided by 47, and then we times that by what it was before, £98.70. And our answer is £100 and 80 pence. Okay, now because of the star on there, I'll be tempted to write that working out down as well. So 48 divide 47 times by, forgot what it was now, £98.70 equals then we're there. So the table shows the price of some clothes in a shop, the price before the increase, the VAT increase, and the price after it. The shop price of some clothes is higher than the price should be after the VAT increase. Which clothes are these? So you're going to do exactly that for each one. So we'll start with the shirt. So you do 48 divided 47 times by £23.50. See what that's equal to. Divided by 47 times £23.50 is £24. So that one's fine. I'll do the same for each one. So trousers were £39.95. So if we type that into a calculator, 48 divided by 47 times 39.95 is £40 and 80 pence. So the shop price is too high on that one, so trousers is one of the ones that's a problem. Next one is the dress. 48 divided by 47 times by, this time it was £95, which is £97 and 2 pence, so that one's going to be too high as well. And we'll check the last one as well, even though it says, oh no, it doesn't say there's 2, so there might be more. £48 divided by 47 times by £35.25 is £36. So that one is spot on. So which ones are a problem? Well, it's the dress and it's the trousers. There's the answers to them. This one, 7C, for the VAT increase from 17.5 to 20, show how the formula was formed. Okay, so to do this, we need to write it as a fraction. So 120% over 117.5% is what it was. So now we need to simplify this. So I would be timesing both by 10 to get rid of the decimal off the bottom to get there. And now simplifying it, well, we can type that into our calculators to simplify it. I should get 48 over 47. So that's where that 48 over 47 bit comes from. Well, hopefully that makes sense. It's kind of tricky. Number 8, scattergrass, always fun. So art against French. Art is 32 and French is 84. Art is 41 and French is 75. art is 62, and French is 30. Art is 84, and French is 16. Art is 90, French is 20. Art is 20, French is 60. Art is 30, French is 50. Art is 45, French is 35. Art is 20, French is 40. And art is 30, French is 20. Okay, so describe the correlation between the two. It's a difficult one, it's very weak. I think that's probably negative correlation. Negative correlation. You could say weak negative correlation, because there are some higher scores here and lower ones there, so it does tend to go down, but it's not very strong correlation. One of the students is chosen at random. Work out the probability the student has a mark of over 50 in at least one of the examinations. Okay, well there's 20 test scores here, and a mark of over 50 is how many of them? 1, 2, let's go out. 1, 2, 3, 4, 5, 6, 7, over 50, so we can't count that one. So there's 1, 2, 3, 4, 5, 6, 7 out of 20. Not quite. Reading that again carefully. Work out probably that this student has a mark of over 50 in at least one of the exams. So actually, how many students got a mark over 50 in at least one of the exams? Well, that one did, and that one did, and that one did, and that one did, and that one did. Okay, so how many of the pupils got that? 6 out of 10. Will be our answer on that one, because 6 out of 10 people got a mark of at least 50, of over 50 in the exams. Hopefully that makes sense. Number 9, simplifying. Well, when we're multiplying indices, we add the little numbers, the powers, together. So it's 6 to the power of 7. And when we're dividing, we take the powers away. So 10 take 5 is 5, so we w to the power of 5. X to the 7, w to the 5. Expand and simplify. Just be careful of that minus sign that we've got there. But it shouldn't be too hard. So your first bracket is 2y plus 6. And the second bracket, 3 times 2y is 6y. Take 3. So now simplifying them, we've got 2y and 6y is 8y. And 6 take 3 is 3. So your answer is 8y plus 3. Next one, complete the table of values for y equals x squared minus 6x plus 7. Okay. So the good thing with these is quadratics should get some sort of symmetry going on. We see we've got 7 and 7 there. So the 2 here means there should probably be a 2 here, and minus 1 there means there'll be a minus 1 there. Okay, so we kind of see what their answers are going to be without doing too much working out. That's going to be minus 1. That's going to be 2. However, probably going to make sense to actually check them and work them out. So the first one, if you type into your calculator and just replace the x that you've got with the number that you're doing in brackets, that's the easiest way to do it. So 1 squared minus 6 lots of 1 plus 7. In your calculators it's going to be 2, which is kind of what you'd expect. So that's for the x equals 1, and then for x equals 4 we put 4 into your calculators. So that's 16 plus 7 is 23, so that'll be minus 1. So you can see how that symmetry worked for us on that one, 2 there, minus 1 there. So, plotting the points, when x is 0, y is 7, x is 0, y is 7, x is 1, y is 2, x is 2, y is minus 1, x is 3, y is minus 2, x is 4, y is minus 1, x is 5, y is 2, and x is 6, y is 7. So plot your points, and then you need to join them up with a nice smooth curve, so not dot to dot, but a curve that makes a sort of U shape. Now I've not really gone through my points very well there, but hopefully you'll be able to go through it a bit better than that. Does the graph go through the point 10, 15? So there's our rule. Is that? So if it goes through this point, well, x is 10, y is 51, so that should be true. So if I put 10 into this, then I should get 51. So y should be 51, and then 10 should equal that. So 100 minus 6 times 10 is 60, plus 7. So 100 minus 60 is 40, add 7 is 47. Well, which is not true. 51 doesn't equal 47. So the graph doesn't go through the point 10, 51. Okay, so in other words, you plug in your x and y values into the rule and see if it holds true or not. If it's true, then it goes through that point. If it doesn't, then it doesn't go through the point. Calculate the shaded area of these 4 identical touching circles with radius 5. Okay, 5 marks here, which is quite a lot of marks, I would suggest. First job, area of square. Well, that's not too bad. The radius is 5, so the length is 10. So it's going to be 10 by 10, which equals 100 centimetres squared. So that's the area of a square. Sorted. Now, area of circle is, what's the area of a circle? And the area of a circle is pi r squared. Apple pies are 2. Okay, so now if I can work out the area of one of these circles, actually that's the same as the 4 white areas because each one is a quarter circle. Now the radius is 5. So pi times 5 squared. Pi times 25. So on a calculator, pi times 25 will give us 78.5398164. Centimetre squared. So finally, shaded area equals area of square minus area of circle. So that's 100, take 78.53981634, which equals so that's 21.46018366, which then, looking at the question, it wants to two significant figures, is 21. And then we're there. Alright, so you've got your square, you've got your circle, take the 2 away, and you should get your answer. Translate triangle A by the vector 3 minus 2. Okay, so the top number tells us left and right, the bottom number up and down. So the 3 tells us we go 3 to the right. 1, 2, 3. If it was negative 3, we'd go 3 to the left. Minus 2 is the up or down, so minus being down. 2. So that is your translated shape there. 13. Solve 6x squared equals 1734, where x is positive. Okay, so first job. X squared is equal to 1734 divided by 6. What is 1734 divided by 6? It's 289. So x equals square root of 289 which is 17. There's your answer, 17. And I guess the only reason it says where x is positive is because minus 17 would work as well, because minus times minus makes positive 289, but x is positive means x is equal to 17. So 13b, diagram shows a cube. The total surface area of the cube is 1734. Work out the volume of the cube. Okay, so we've got 6 sides to this, which has got a total surface area of 1734. So area of one side is going to be 1734 divided by 6, because 6 sides. So that's going to equal 289. Hopefully you can see the link now to the question that we've got up there. So now length of one side is going to be the square root of 289. Which is equal to 17 centimetres. So now the volume of cube is the length times the width times the height. 17 cubed, in other words. So what is 17 cubed? .4913 centimetres cubed. Diagram shows two similar triangles. Work out the value of y. Okay, so we're looking for the number that we multiply to get from one to the other. To do that, we do 8 divided by 10. 0.8. Okay, so that's 0.8, which means that if I times by 0.8, I can go from the bigger rectangle to the smaller rectangle, like so. So now I've done that, y is going to equal 4 times 0.8, which is 3.2 centimetres. There we go. So 15, the diagram shows a tank containing water. The tank is 1/3 full. The tank measures 25 by 10 by 45. The tank is now filled at a rate of 250 per minute. How long will it take to fill the rest of the tank? Okay, so because it's 1/3 full, the first thing we really need to do is work out the length from, I'll do it over here, from there to there. That length there. Okay, so that length there is going to be 2/3 of 45 centimetres, which is 30 centimetres. So that length there is 30 centimetres. Okay, so now the volume left to fill is equal to the height, 30, times the base, 25, times the depth, 10. So 30 times 25 times 10 is going to be 7,500 centimetres cubed. So that's what we've got left to fill, and that's going to get filled at 250 centimetres cubed a minute. So time to fill is going to be what we've got left to fill, 7,500 divided by the speed that's going to happen, 250, which is going to be 30 minutes. Number 16. Factorise this. I need to make that a bit bigger. Okay, so factorise that. Before I factorise it, I'm going to have to expand the brackets. So first of all, what does that stand for? That stands for c plus 3 squared. Okay, no, I don't need to do that at all. What have I got which is common to both the first term, c plus 3 squared, and the second term, 2c plus 3? Well, there's a c plus 3 in both of them. So that's what I take out of the brackets. Now inside the brackets, I need another c plus 3. Because then c plus 3 times c plus 3 will give me c plus 3 squared minus 2. Because 2 lots c plus 3 will give me that there. So far so good. So now to sort that out, well, I can't do nothing to c plus 3, but on this bit here, c plus 3 minus 2, or 3 minus 2, is 1. So that is equal to c plus 3, c plus 1. What you could do is you could have expanded this bracket out and this bracket out, and then simplify it, and then factorise into double brackets. Would have got you the same answer, I think. Make x the subject of this here. So to make it the subject of means to make x equal to. So First job is to expand that bracket, 4x plus 4y, and that is equal to 7y minus 5. Now I need x on its own, so I'm going to take the 4y off of this side. So it's going to give me 4x equal to, and if I take 4y off this side, I'm going to get 3y minus 5. And then finally, if I want to make that x equal to, I've got to divide by 4, which means I've got to divide that by 4. So your answer is 3y minus 5 over 4. So, given that x is a number between 0 and 1, not including 0 and 1, what of these are true? So let's try some numbers. Let's go with x equals 0.5 for the first one. So then 0.5 squared is 0.25, which is greater than 0.5. So that's true. We could try 0.2, 0.2 squared is 0.04. So let's start again. 0.5 squared is 0.25, which is not greater than 0.5. So in fact, actually, that's going to be never true. For these ones, 0.5, if I try 0.5, 1 divided by half is going to be 1, which is going to be 2, sorry, which is not greater than 2. But if I try 0.6, then that is going to be true. So I think that's going to be sometimes true. He says. Alright, the diagram shows a right angled triangle, show the perimeter is 84. Right angled triangle means it's Pythagoras. Write your rule down. C is 35, and we don't know what the shorter lengths are yet, so 3x and 4x. So now if I do 3x squared, that's going to be 9x squared, because you square both the number and the algebra, and 4x squared is going to be 16x squared, and 35 squared is 1225. I can put into my calculator. So now combining them together, I've got 1225 is 25x squared, divide by 25, tells me that x squared is equal to 49, which means that x is going to equal 7. So I can get myself down to what x is equal to, and now I can just work it out. So 3x is 3 times 7 is 21 centimetres, 4x is 4 times 7 is 28 centimetres, so perimeter is 21, add 28, add 35, which is equal to 84 centimetres, which is what it wants us to show. Number 18, the mass of the Sun is that. The mass of Earth is that. How many times heavier is the Sun than the Earth? So to work that out, we're going to divide the numbers. So it's going to be 1.99 times 10 to the power of 30. Divided by the mass of the Earth, which is 5.98 times 10 to the 24. So the key to this is knowing where your standard form button is on your calculator. A lot of them have times 10 to the x on them, so I'm going to say exp on them to work them out. calculator. Trying to find the button on here, so it's the EXP button on here. So it's 1.99 EXP times 10 to the power of 30. Close the bracket, and then we're going to divide that by 5.98 EXP 24, and then you get your answer there. So that is 332.775.919732. So there's your answer. So to an appropriate degree of accuracy, well, these two are 2 decimal places, so I would say that we'll go equals 3.32 times 10 to the power of 1, 2, 3, 4, 5 times 10 to the power of 5 is your answer. Solve 5x squared minus 6x minus 2 equals 0 to 2 decimal places. So again, as soon as you see you've got a quadratic and the question says to 2 decimal places, so solving quadratics to 2 decimal places, you know you're going to need the quadratic equation off the front of the book to work out the answer. Alright, so x equals minus b plus or minus b squared minus 4ac over 2a, where for us we've got a equals 5, we've got b equals minus 6, and we've got c equals minus 2. So, putting them in, we get there, minus b, minus 6 is 6, plus or minus b squared, minus 4 times a times c, all over 2 times a. So now working this out, minus 6 squared is going to be 36, 4 times 5 is 20, times 2 is minus 40. So we've got 6 plus or minus 36 minus 40, divide by 10, 2 times 5. Now 36 minus 40 is going to be 36 plus 40. So we're going to get to there. 6 plus or minus root 76 over 10. So now we just type into our calculator 6 plus root 76 equals, then divide by 10, gives us 1.47177979. 1.47 to 2 decimal places. If we do 6 minus root 76 and then divide that by 10, then we get minus 0.271777979, which is 0.272. Now, this is where you've got to be a bit careful. And make sure you answer the question. It says 2 decimal places. So we need to make sure that we round it to what the question says. So just check before you go on the next question that you've done exactly what they're after. But hopefully that's okay. Simon runs 800 metres in 1 minute 52. The distance is correct to the nearest 10. The time to the nearest second. Calculate the Simon's maximum possible speed. Okay, so speed is distance divided by time. So I want this to be as big as possible. I want my distance to be as big as possible, and my time to be as slow as possible. So my speed, my maximum speed is going to be my max distance divided by my min time. So the max distance it could be, let's correct to the nearest 10 metres. No, hold fire a minute. The maximum speed. No, I've got that the wrong way around. If I want the maximum speed, I want the distance to be as low as possible and the time taken to be as quick as possible. No, I was right in the first place. What am I on about? Because a big number divided by a small number is going to give that as big as possible. So the max distance is going to be 805. Divided by the minimum time, which is 1 minute 52 to the nearest second is 1 minute 51.5 seconds. Okay, so now to do this further, we need to make that minutes into just seconds. So 60 seconds in a minute is going to make that 111.5 seconds. So calculator, 805 divided by 111.5 is going to be 7.219730942. Into 7.22. Three significant figures, and I want you to state the units of your answer. So that's meters per second. And we're done. Alright, number 21, diagram shows a trapezium, work out the area of the trapezium. So there's your rule for area of trapezium, half times A plus B added together times the height. So we've got ourselves our A and we've got ourselves a B. What we don't have is our height. So to do that, we need to look at this triangle that we've got here, where this is 7.1. The angle in there is 32, because we've got 90 there, and the height is what we're trying to work out, which I've called X for now. So to do that, we're going to use ourselves a bit of trigonometry. Which one is it? Well, if there's our angle, we know the hypotenuse, we want the adjacent, so we're looking at this one here, the cosine, vit, and we want the adjacent, so we're going to do the cosine of the angle times by h, the hypotenuse. So x equals cos 32 times the hypotenuse, 7.1. So, calculator out. Cosine 32 times by 7.1 is 5.922986 centimetres, which we can round to one decimal place, 5.9 centimetres. Okay. So now if we go for our trapezium, of trapezium equals half the sum of the parallel sides times the distance between them. for us, or A add B, is 9.6 plus 6.4, and the height we just worked out to be 5.9. So that is 9.6 out of 6.4 is 16. And if we type that into a calculator, we'll get the area, which is 47.2 centimetres squared. And then we're there. 22 in a bag, there are 45 counters, 28 are white, 2 are chosen at random without replacement. What is the probability that they are both white? Give your answer in its simplest form. So 28 are white. So the probability of getting that on your first one is 28. And then the probability of getting a white on your second one, well, there's 27 now. Up to 44 altogether. So probably then both happening, we multiply the two together. Now on your calculators that might be capable of typing them in and getting straight to a simplified form. If not, then 28 times 27 is 756, and 756 divided by 1 over 1980. So simplifying that, we can go that far. 189 divided by 495. Which can go further to be in 63 over 165, which is 21 over 55, and then that's as far as we can go. So 21 over 55. Winner. The times that some teachers take travelling to school are shown in the histogram. 42 teachers take between 10 and 20 minutes travelling to work. What is the probability that the teacher chosen at random takes more than 30 minutes? Okay, so for histograms you've got two rules. Frequency density is frequency divided by class width. Or if you rearrange that, you've got frequency as frequency density times class width. You need to know them. So make a note of them first. Now for us on this question here, it hasn't done the scale for us on the frequency density. All we've got is a bit of information that says between 10 and 20. This section here, there are 42 people. So what is the frequency density there then? The frequency density is the frequency, well it tells you it's 42, divided by the width. Well, 10 to 20 is 10. So that is 4.2. So I've got that far, as that being 4.2. I can then work out the rest of the scale. So that there is 4.2. There's 1, 2, 3, 4, 5, 6 going up to there. So 4.2 divided by 6 is 0.7. 0.7, then we'll have 1.4, then we'll have 2.1, then we'll have 2.8, then 3.5, 2, 3, 4, 5, 6, 7. Not concentrating. 4.2 divided by 7 is 0.6, so 0.6 will be your first one, and then we're going up in 0.6. So 1.8, 2.4, 3.8, 3.6, 4.2, and 4.8. Right then, so there's our frequency density that we've got there. The scale going up the side there. Move that out of the way. So now what is the probability the teacher chosen at random takes more than 30 minutes to get to the school? Okay, so what we really need to know is how many teachers there are at the school. So for the first bit, the frequency between 5 and 10 is 4.8. Frequency density times the width, 4.8 times 5, which is 24. So it's 24 in that first bar there. The second bar we already know is 42. The next bar, the frequency is the frequency density, 3.6 times the width, which is 5, 10, 15, 20. Ooh, what's happened there? So that is 72. So that's 72. The next little bit is the frequency density is 1.8 times the width, which is 5. 1.8 times 5 is 9. So that bar is worth 9. And then finally, the frequency is 0.6 times by 5, 10, 15, which is 9 as well. So that's that there. So how many teachers have we now got altogether? Well, we've got ourselves 24 plus 42 plus 72 plus 9 plus 9 equals 72, 81, 90, 506, 156 teachers altogether. And if we want to work out the probability they take more than 30 minutes, then we're looking at this section here. Well, that's half of them, which is 36, plus 9 is 45, plus 9 is 54. So 54 out of 156 teachers take more than 30 minutes. Cool. Alright, last one. A bag contains only red, blue and white counters. A counter is chosen at random. The probabilities are 4 over x, 7 over x minus 3, and red is a half. Work out the value of x. Right, the key to this is knowing that if the red is a half, then these two, the blue and white together, must make a half as well. So 4 over x plus 7 over x minus 3 has to equal a half. So now I've got to solve myself these algebraic fractions. So to do that, the first thing I've done is I've multiplied everything by 2 because I want to get rid of the half, because that was awkward. So you just times the numerators, so that'll be 8 and that'll be 14 over the same numbers. Right, then if you times everything by x, you get 8 here, 14x there, and x there, and x minus 3 goes there, gets rid of it there, and goes on the end here, so you end up with 8 lots of x minus 3 plus 14 lots of x equals one lot of x times x minus 3. Expand the brackets out then. 8x minus 24 plus 14x equals, well, I just lost the 1 there, so x minus 3. How's it going? So 22x minus 24 equals x squared minus 3x. So I've expanded the bracket here and I've put together my x's. Now I've got myself a quadratic here, so I want to make it equal to 0 by taking these two onto the other side. So I'll take 22x over, I get minus 24 equals x squared minus 25x. If I take the 24 over, I get x squared minus 25x plus 24 equals 0. And then final step, I'll just turn it around so it looks nicer, is equal to 0. So a whole load of algebra there to work through. Okay, hopefully it makes sense. I think this line here is the key one. So it makes sense if you can do that. Then after that you should then be able to rearrange to get your quadratic is equal to 0. Okay, so now we've got to solve this quadratic. I've moved it up there. Now then, it doesn't say anything about 2 decimal places and things like that, so I reckon this is going to be a factorisable into 2 double brackets. And yeah, it does. X minus 1, x minus 24 equals 0, because x times x is x squared, minus 1x, minus 24x gives us minus 25x, and minus 1 times minus 24 is positive 24. So x is equal to 1, or x is equal to 24, because then we get a 0 here or a 0 there to make our 0 overall. So finally, to finish off, we now just got to see which one of these is true. Well, if we take x is equal to 1, then I can put that into this one here, or 4 divided by 1 is 4. Well, I know that the probability of something is somewhere between 0 and 1, so 4 isn't any good. Similarly on this one, if I do 1 minus 3, I get negative 2, and 7 divided by that, I get minus 3.5. You can't have a probability which is negative. The lowest it could be is impossible, or 0. So x is going to have to equal, can't be that one, x is going to have to equal 24, because that's the only one of the two answers that makes any sense. And then we're there. Alright, job done. Any questions, come and find me or speak to your teacher, and we'll be only too happy to help.